Okay, hello everyone. This is an epidemiology course, and today's chapter is chapter 4 about basic measurements in epidemiology. So, basic measurement in we will see the basic measurements in epidemiology in this chapter 4 section. So, this is the lecture outline. This is the lecture objectives, learning objectives, and basic measurements in epidemiology. Measurements in morbidity, measurements in mortality and disability, natality, and measurements in the presence, absence, or distribution of characteristics attributes of the disease. So now introduction about measurement in epidemiology. Measures of disease frequency are the basic tools of epidemiological approach. Epidemiology is mainly quantitative science. One of the central concerns of epidemiology is to find and enumerate appropriate denominators in order to describe and compare groups in meaningful and useful way. Such measures allow direct comparison of the disease and frequencies in two or more groups of individuals. So, measures of disease frequency. Health status of the community is assessed by the collection, analysis, interpretation of data on illness or morbidity, on death or mortality and disability, and utilization of health services. So to measure quantity, to measure and quantify such events, we have been using epidemiological tools. These epidemiological tools are count, ratio, proportion, and rates. So ratio, proportion, and rates are the most common. So the number of cases in a given community can give more epidemiological sense if they are related to size of population. The number of cases with population size can be determined by calculating ratio, proportion, and rate. So it's the most common. So the number of cases with population size means there is number of cases numerator and population size is denominator. So these three things are also considered, these two criteria. Now let us see ratios. Ratio quantifies the magnitude of one occurrence or condition to the another. So means compare the magnitude of one condition to the magnitude of other condition. So ratio is to quantify the magnitude of one occurrence to the magnitude of the other occurrence. So ratio expresses the relationship between two numbers in the form of xy or x over y. So means xy means, for instance, there is male here, there is female here. For instance, if male is 2 and female is 3, either we can put it as 2 ratio 3, or we can say 2 divided by 3. So this compares males to females, meaning to compare two numbers means the value of males to the value of females. The value of x and the value of y may be completely independent. The value of x and the value of y may be completely independent. This means this value and this values are x and y value, or male and female value, are independent. That means males are different independent group and females are different independent groups. That means male to female ratio or male to female ratio is independent. Male number and female number are independent. And the second type of epidemiological tool is proportion. Proportion is ratio expressed as percent, in which x is included in y. This is not independent. That means this is x over y. So x is included in y, meaning there is male here over male and female, meaning total population. So males are found on the denominator, so this is not independent. So the proportion of males in the population means male over both sexes, male and female. So males are found on the male are numerator, so it's found also in the denominator. But in the case of ratio, male over female, so males are not found in the female, on the denominator. So say among 100 children and 58 are found to be diseased. What is the proportion? So total population is 100, 50% is diseased occurrence, so 58 over 100 is a proportion. So the proportion of children with disease is 58 divided by 100. This means 0.58 is a proportion. So 0.58% is a proportion. We can calculate by this way. The third one is rate. Rate is the most important epidemiological tool used for measuring disease. The most important epidemiological tool used for measuring disease. Why rate are the most important? Why makes rate most important? Because rate is a special form of proportion that includes time. That's why rate is includes time period. That's why the most important. So most otherwise rate and proportion is similar, but time period or time dimension included in the rate. Most commonly used in epidemiology because it clearly expresses probability or risk of disease. So that makes the most important is because of time, it expresses probability or risk of disease. Other events in defined population over in specified period of time. So rate expresses the probability or risk of disease in defined population over a specified period of time. This makes different, okay? This makes the most important epidemiological tool and commonly used. So defined population, specified period time makes to calculate the probability or risk of disease. So rate is the most important epidemiological tool as compared to proportion and ratio. A rate is derived from three pieces of information. The one is numerator, denominator, time period. So numerator, the number of individuals diseased or died, for instance 58, the previous 58, and denominator, the total number of individuals in the study group or period, 100. That's the previous example. So 58 is numerator, 100 is the denominator. So and time period for how much time period they followed. So times 100 or 1000. So this is a time period. This is a rate, which includes a piece of information, these three things. And the other is rate. Rate can be calculated. Rate is equal to the number of events in the specified period divided by the average population at risk of these events in the specified period times by k. K means it may be 100, maybe 1000. That means k is responsible to remove the decimal. So maybe 100 or maybe 1000. So this is new events or 58. This is average population at risk. This is 100. So the number of newly diagnosed cases of breast cancer per 100,000 women during 1999. So 1999 is a specified time period. So newly diagnosed cancer is per 100 women during 99. So the number of newly diagnosed cases of breast cancer per 100,000 women during 99 time means an example for a rate. So examples of rate may be fertility rate, morbidity rate, mortality rate. Also rate applied for these three categories. And fertility, morbidity, mortality rates are three frequency measures that are used to characterize the occurrence of health events. So there are three types of rates: crude rate, specific rate, adjusted or standardized rate. When we see the crude rate measures the total population. An example is crude birth rate. Specific rate measures the subgroups. For instance, age specific days rate. So the third one is rate after adjusting for specific group like age, sex is called adjusted rate or standardized rate. So when it came to the three measures, frequency measures, rate, ratio and proportion, let us compare them. There is a ratio is numerator included in, there is a ratio here, x to y. So is numerator included in denominator? If our answer is yes, no, it is a ratio. If numerator included in denominator, if the numerator does not include in denominator, it is ratio. If numerator is included in denominator, it is proportion. So either proportion or it can be rate. In the rate or in the proportion, numerator is included in denominator, but the difference is time. So is time included in the denominator? Yes, it's a rate. No, it's proportion. So in proportion, numerator is included in denominator, but there is no time dimension. But in a rate, numerator included in denominator, but there is time dimension. So this rate. So rate is for rate, an example is incidence rate. It's risk. As for proportion, it's prevalence rate. Ratio is maternal mortality ratio. So the measurement of morbidity. Morbidity rates are rates used to quantify the occurrence of disease. Morbidity has been defined as any departure from a state of physiological, psychological well-being state is called morbidity. Morbidity encompasses maybe disease, illness, injury, disability, or any other disorder in public health practice. Measures of morbidity include prevalence and incidence. So measures of morbidity is prevalence and incidence. Now we will see the prevalence. Prevalence measures the number of people in the population who have a disease at a given point or at a given period in time. So prevalence means the number of people in the population who have the disease at a given point or period in time. So prevalence estimates how many cases, how many new and pre-existing cases are found in particular point of time or in period of time during specified population or population at risk. So this is known as prevalence, a measure of disease status or disease burden. By the way, prevalence shows us about the disease burden in the one's community. It differs from incidence in the because prevalence includes both new and pre-existing cases in the population at specified time. So the difference is that prevalence includes both new and pre-existing cases at specified time, whereas incidence includes only new cases. And also it will include some specific period that has that populations are followed. The followed period is needed in the incidence. So this is the difference. So when we say the prevalence of common cold in this class or one's class, if the number of cases people with colds in the class among 30 students is 3, then the prevalence of people with cold will be, so for instance in one class there are 30 students. From 30 students, 3 students have common cold. So what is the prevalence? The prevalence is 3. The prevalence is the case is 3. The total population is 30. So 3 over 30 is the prevalence. That means 0.1 is the prevalence times 100, 10%. Times 100% is 10%. So 10% of people, the 10% of individuals in the class have developed common cold. But in this case, there may be new case, there may be existing case. It composes all. So types of prevalence. Prevalence can be divided into two: point prevalence and period prevalence. Point prevalence means the number of cases that exist at a given point in time. Point prevalence is the number of cases that exist at a given point in time. So both point prevalence means includes both new and existing cases that exist at a given point in time. At a given point in time, one specified time, one particular point of time. The number of new and existing cases at point in time is called point prevalence. Applies when the data has been collected at one point in time. At one point, the data is collected at one point in time. So point prevalence is equal to the number of observed cases at time t, or at specified time t, over population size at time t, is called point prevalence. Point prevalence. So when an example, among 150 children in the school screened for refractory error at time t, 50 children have problem and require glass. What is the prevalence of refractory error? That means, since it is asked at time t, it is point prevalence. So the number of cases are 50. The total population in the class is 150. So 15 over 150 times 100 is the point prevalence. So it is 10%. It is 10%. So the other is period prevalence, PP. Period prevalence is the number of cases that exist. Number of cases means new plus existing cases in the population during a specified period in time. Point prevalence is at particular point in time, but this is specified period in time. There is some duration. So the difference is this, the period in time. So the measures of frequency of disease over some time. So this point prevalence measures frequency of disease at point in time, whereas period prevalence measures frequency of disease at some time, over some duration. And period prevalence used when it's difficult to know when the disease is considered present, and period prevalence applies when the data has been collected over a period of time, and not used frequently. Commonly it is not usable because it combines both point prevalence and incidence in single parameter. Meaning period prevalence is equal to the number of prevalent cases at the beginning of the time period. This means point prevalence, and incidence, the number of incidence cases that were during the period, incidence, over the size of population for this time period is n. So period prevalence equal to point prevalence plus incidence over total population. So this means it includes point prevalence plus incidence. So prevalence rate, the count of cases, new and old or previous, at the point in time in a population size defined by characteristics and place, is prevalence rate obtained from cross-section. Mostly prevalence rate is calculated from cross-sectional studies and disease registries or survey, is a prevalence rate. So prevalence rate is equal to all cases, that means new cases plus existing cases, over population at risk times 100, maybe 1000. It is to remove decimals, so 100 means k, maybe 100 or 1000 or 10,000 or 100,000. So prevalence rate is equal to all cases over population at risk times k is a prevalence formula. So let us see one or more examples. So in one class the population is 150 individuals. There is follow-up for 1 year. 25 had diseases of interest at the beginning. At the beginning of the study there are 25 individuals who have disease, but another 15 cases developed during the year. So this concept is that in one class there are 150 individuals. So these individuals followed for 1 year, but when you start the study you have got 25 individuals who have disease, but after starting the study you have new cases that develop during the follow-up time within 1 year. That is 50 new cases. So calculate the point prevalence and period prevalence. So when we calculate point prevalence is equal to cases over population. So the point prevalence means cases in the beginning. So in the beginning there are 25 individuals who have disease, so 25. So the total population 150, 25 over 150, 0.17, or at 70% is point prevalence. Point means in specified period in time, not follow-up. So you will take as the beginning. Whereas period prevalence means point in time plus follow-up. Incidence means follow-up over population. Meaning point prevalence is 25 as the point in time, as the beginning, plus during follow-up, during the duration of time, during the follow-up time, during the follow-up period. This is 15. So over 150, so this is 27%. So period prevalence 25%, point prevalence is 70%. The other uses of prevalence data. Prevalence data is important to assess healthcare needs, planning health services, tracking changes in disease pattern over time, to study chronic disease, monitoring disease control programs, and to study the burden of disease. So these all are uses or importance of prevalence data. The other is factors influencing prevalence. All these are factors which affect the prevalence, magnitude of the prevalence. So prevalence can be increased if there is longer duration of the disease, if prolongation of life, if there is prolongation of life of patients without cure, because since prevalence is estimated in point in time, if the disease is longer duration of disease, you may get that disease if you start at different time. Prolongation of life of patient without cure, that means without cure means there is prolongation of disease, prolonged duration. That means you have got the disease if you study or start at different point in time, within 1 year or within 5 years. The other is increase new cases or increase incidence. If there is new cases, the prevalence also will be increases, because prevalence includes new cases plus existing cases. The other is in immigration of cases. In immigration means if some cases are added from outside the country to the inside country, or outside the community to inside the community. The other is out migration of healthy people. That means if healthy people is out of or migrate from your community, so since the healthy people are migrated, so the healthy people decreases means it will decrease the total population, so that they will decrease the prevalence. They will increase the prevalence since the healthy people decreases. The other is in migration of susceptible people, meaning if susceptible people are entered into your community, the cases or the new case will be increases, so increase the prevalence. The other is improved diagnostic facility. If diagnostic facility increases, more cases will be identified, so that the prevalence will be increased. If there is better reporting, more cases are reported accurately, so the prevalence will be increased. So all these are increases the prevalence, whereas all these are decreases the prevalence. So shorter duration of the disease decreases the prevalence, high case fatality rate decrease the prevalence, decrease in new cases or incidence, in immigration of healthy people, out migration of cases, improved cure rate of cases. These all are decrease the prevalence rate. So all these are factors that influence the prevalence. So when we compare and contrast incidence and prevalence, this is a funnel. This is for instance, this is some machines, and this is maybe something product. So this product is poured here, starting from latter. So all previous poured contents or products are prevalence here, prevalence. But the newly added products are incidence. The newly added products are incidence, said to be incidence. But in prevalence, there are some individuals which leave the prevalence population. That means due to either recovered from disease or death from the disease. So from the previous to the current is prevalence, whereas the newly added is incidence. This is the difference between incidence and prevalence. So the other is incidence. The other measures of morbidity is incidence. Incidence of disease is defined as the number of new cases of disease that occur during a specified period in time in a population at risk for developing disease, called incidence. Period in time is maybe a day, maybe a month, maybe a year. So the number of new cases that occur during a specified period in time at population at risk is called incidence. That means new cases of disease, the number of new cases of disease is numerator, population at risk is denominator, and period in time means its follow-up period. So these three things should be fulfilled in incidence. So the new case of disease is incidence, but if it is prevalence, new cases plus existing cases or old cases. So incidence rate is equal to the number of new cases of disease over a period of time divided by population at risk during a given time period times k. K means it may be 100, it may be 1000, it may be 10,000. It is intended to remove the decimal. So number of new cases over population at risk is called incidence rate. Incidence rate means only include new cases that is developed during a specified period of time. Risk is a likelihood or a probability that an individual will contract or will get the disease. The proportion of unaffected individual will contract the disease of interest over a specified period of time is a risk. The probability or the proportion of unaffected individual or disease-free individual will get the disease of interest over a specified period of time is a risk. So different from causation, chance. It is a chance that if exposed to certain risk factor will develop a condition. Risk factors are factors that increase the probability that disease will occur. So since incidence is a measure of new events, that means new event means from transition from non-diseased to diseased state, incidence is measure of risk. So incidence studies a measure of risk that an individual or disease-free individual will contract the disease. So it's a risk. So incidence is estimates a risk, or it's a measure of risk. For incidence to be meaningful, any individual who is included in the denominator must have the potential to become a part of a group that is counted in the numerator, meaning populations or individuals as the denominator is population group, population of risk groups that maybe have a probability to be included in the numerator. That means if that risk population at risk individual, if diseased, it will be counted or included in the numerator. So that's why incidences should consider populations at risk. So populations in the numerator were or included in the denominator, and denominator have a probability to be diseased in the future and became numerator. So in May 1995 there were 50 new cases of relapsing fever in Qebele A. The average total population of Qebele A was 5,000. So in that 1995 there is new case of relapsing fever, that is 50, and the total population at risk is 5,000. So calculate the incidence rate of relapsing fever. So incidence rate is equal to new case of disease, that is 50, population at risk, that is 5,000, times 1,000. It is 10 new cases per 1,000 population. It is 10. That means out of every 1,000 people that was living in Qebele, 10 of them acquired relapsing fever in May 1995. So every 10 people, every 1,000 people, 10 of them acquired relapsing fever. So the incidence rate is 10%. So types of incidence. Incidence can be divided into two: cumulative incidence and incidence density. Cumulative incidence is similar to incidence proportion. Incidence density is similar to incidence rate. So cumulative incidence is a risk of disease or measure of average risk. It estimates risk, so measures of the proportion of persons who develop disease in the known span of time. So cumulative incidence provides an estimate of probability that an individual will develop disease during a specified period of time. So cumulative incidence answers question: what is the probability or chance that an individual develops the outcome over time? So cumulative incidence is equal to number of new cases or population at the beginning times 10 to the power of n. N is maybe 1, 2, 3. So that means 100,000 and 10,000. So the number of cases newly diagnosed HIV infection in CTB is 900. Population in cities, population at risk is 100,000. So the incidence of HIV in CTB is 900 per 1,000 in 2002. Another example is, in the study of diabetes, 100 of 189 diabetic men died during 30-year follow-up period. Calculate risk of death for this mean. So numerator 100 cases, denominator 189. So risk is 100 over 189 times 100. So 52.9% is risk. An outbreak of gastroenteritis among attendants of corporate picnic, 90% ate potato, 30 of whom developed gastroenteritis. So 99 is eat, that means at risk, 30 are cases. So calculate the risk of illness. So numerator is 30, denominator is 99. So risk is equal to 30 over 99 times 100, that is 30.3%. Properties of incidence proportion. It is a measure of risk of disease or probability of developing the disease during a specified period in time. As measure of incidence, it includes only new cases of disease in the numerator. The denominator is the number of persons in the population at risk at the start of the observation time, applicable for only static population of cohort, meaning incidence proportion is used for static population of cohort, means while incidence density is for dynamic population. Incidence proportion is for static population. That means static population is stable population. So incidence density, we will start about incidence density and all others in the next section. So we will start incidence density in the next portion. Don't forget to subscribe this channel to get the next videos. So enjoy this video. Thank you very much for watching this video and have a nice time.